Electric network elements, storage technologies. In this video, we'll talk about storage technologies. At the end of this module, you will be able to identify technologies for electricity storage. Energy storage technologies encompass a large set of diverse technologies. They can broadly be classified into mechanical, electrochemical, chemical, electrical, and thermal energy storage systems. Vast majority of today's energy storage devices are using mechanical energy storage in the form of pumped hydro storage compressed air and flywheel storage. Pumped hydro solutions are used with the most success due to their fast response and large energy storage capacity. This technology makes use of two water reservoirs at two different elevations with a pump generator unit connecting the two. This is used to generate electricity during peak hours by allowing water to flow from the upper reservoir to the lower one, spinning the generator. During off-peak hours, the pump is activated to pump water from the lower reservoir back to the upper one. Their long lifetimes and stability are what makes them ideal storage systems. However, technical and commercial issues have prevented their large-scale adoption. Compressed air, compressed gas energy storage is a technology known and used since the 19th century for different industrial applications, including mobile ones. Air is used as a storage medium due to its availability. Electricity is used to compress air and store it in an underground cavern or purpose-built structure. When needed, the compressed air is mixed with a fuel, like natural gas, and then used in a modified gas turbine. In flywheel energy storage, rotational energy is stored in an accelerated rotor, which is usually a massive rotating cylinder that is kept rotating in a vacuum. The energy is maintained in the flywheel by keeping it rotating at a constant speed. An increase in speed results in more energy stored. To accelerate the flywheel, electrical energy is supplied by the motor generator to the flywheel. To produce electricity, the flywheel's rotational speed is decreased by the motor generator unit. Today, flywheels are commercially deployed for power quality in industrial and UPS applications, mainly in a hybrid configuration. In electrochemical storage systems, the electric energy is stored in chemical bonds in different types of battery cells. These cells are usually specifically designed for use in the power grid. Electrochemical storage systems have an advantage over other storage solutions, as it has a small footprint and has no restrictions on geographical location of which it can be set in. In addition, electrochemical solutions usually have a faster ramp rate and response than those of mechanical storage systems. From the battery technologies today, lithium-ion technology offers high energy and power densities that are suitable for utilizing at the distribution level on the power grid. The drawback of electrochemical storage systems is a lower lifespan compared to other solutions and cost. Electrical energy can be stored chemically by producing hydrogen or synthetic natural gas as secondary energy carriers. The main purpose of this type of energy storage is to use the excess electricity to store it chemically in some sort of gas. Once the gas has been produced, different ways are available for using it as an energy carrier. Although the overall efficiency of this type of storage is lower, compared to mechanical and electrochemical storage, chemical energy storage is the only concept which allows for storage of large amounts of energy, up to terawatt-hour range, for greater periods of time. In addition, an advantage of this type of energy storage is that the gaseous energy carriers are universal and can be used in different sectors, such as transport and heating. Electrical energy can also be stored in electrical storage systems. This is done by utilizing supercapacitors that are filling the gap between classical capacitors and general batteries. Their main advantage is nearly unlimited cycle stability as well as extremely high power capability. Supercapacitors can reach a specific power density which is about 10 times higher than that of conventional batteries. But the energy density of supercapacitors is about 10 times lower than those of battery energy storage. Because of their properties, electrical storage systems are suited especially to applications with a large number of short charge-discharge cycles, where their high performance characteristics can be used. They are not suitable for the storage of energy over longer periods of time because of their high self-discharge rate, their low energy density, and high investment costs. Thermal energy storage systems store heat by different means in an insulated repository for later use. In the context of electrical energy storage systems, this is mainly utilized in concentrated solar power plants, where the plant produces heat by concentrated sun rays, which is then stored before conversion to electricity. Today, a two-tank system is used, with one single molten salt tank as a heat transfer and a second one as a storage medium. The molten salt is heated and then transported to the hot salt storage tank. To produce electricity, the hot salt passes through a steam generator, which powers a steam turbine. To conclude, there is a wide range of technology to store electricity and more widely used energy based on different physical principles. These technologies can store energy over a small time span, such as seconds or minutes, to a larger time span, such as weeks or even months. Thanks for watching.